Qwen 3.6-27B has just dropped, and it is a completely free, open source, dense model that crushes paid giants in real world benchmarks. Today I will show you how you can use it for free and also run 5 real world test cases to prove its capabilities. So let's dive in. This 27 billion parameter model is completely changing what free open source AI can do on your own machine. This isn't a 4 billion parameter huge model that requires a supercomputer to run. It is highly optimized 27 billion parameter model, and as it is a dense model, every single parameter fires on every word that you type on it. And it scores massive 53.5 on SWE Bench Pro benchmark, which is at par at the other frontier AI closed source models like Claude, Gemini, and it easily beats the previous versions of the Qwen models as well. With these kind of benchmark scores, it can jump into private enterprise code bases easily and fix complex bugs without any human intervention. And it is actually beating its older brother Qwen 3.5 397 billion parameter model, which is really huge compared to the current 27 billion version. But still, if you look at all the coding benchmarks, it is able to outperform. Like here, it has scored 59%, while the older 397 billion parameter model was scoring 52. Similarly, in agentic coding, it is scoring 53 versus 50, then 77 versus 76, and in multilingual task as well, 71 versus 69. So yeah, Qwen company spent millions of dollars to train a 400 billion parameter model, only for it to get beaten by a 27 billion parameter model a month later. So let's look at how this model is different from the previous versions of the Qwen models. Most of the previous versions of Qwen use this MOE architecture, which is mixture of experts, which was a trick to save compute power, allowing the model to only fire some specific parameters at once for any user query. For example, this 3.5 397 billion parameter model had 397 billion parameters in total, but at a time it only fired 17 billion active mixture of expert parameters. But Qwen 3.6 abandons that. It fires all 27 billion parameters for every single token used. So the computation would be heavy, but the results would be a rock solid, unbreakable logic chain followed by the model from end to end. If you look at its model card on Hugging Face website, you will see that it has a massive context window of 260k tokens, which is extensible up to 1 million tokens. So you can literally drop an entire documentation and ask it to build an app using those exact instructions. It also supports multi-model thinking and non-thinking modes, so it can process code and images natively using the same brain, making it hyper accurate for front-end development and UI debugging. In benchmark scores as well, it scored 59% in terminal benchmark, which is a test in which AI sits in a raw terminal, finds system errors, and write the correct scripts like a software engineer. The absolute standout feature for this new version is the preserved thinking mode, by which it remembers its entire thought process across the entire conversation history. Most of the standard AI explain its logic on prompt 1, but after you give it multiple prompts, it just forgets what were the instructions in the prompt 1 given. But this preserved thinking fixes this. This new version has been additionally trained to preserve and leverage thinking traces from historical messages as well. So it can remember its reasoning and thinking process across the entire chat. It remembers not just what it wrote, but exactly why it wrote it. So while using this model, you can also enable this behavior by setting preserved thinking option to true. So when we are calling this model, we can use this preserved thinking parameter like this. So you can tell it to modify a Python file and add some functions to it. Then you can follow up an hour later asking for the error logs, and it will use the previous logic to place the logs where exactly the bottlenecks are in the functions. This turns AI into a consistent agentic partner that manages massive repository updates over a long time without ever needing to handhold. To start using this model on your local PC, you're going to need Ollama. So just go to ollama.com/download and download the installer according to your platform. Then you can go to the Qwen 3.6 page on this Ollama site, scroll down below and select the 27 billion parameter version. And then you can just copy this query and paste it in any Python terminal like Google Antigravity. Just note that you will need 32 GB or 64 GB graphic card in your system and 17 GB of free space in your hard disk to download this model and run it smoothly on your own local PC. For testing it right now, I'm just going to use chat.qwen.ai and I'm going to select the Qwen 3.6-27B version here. You can also use these same prompts in your project if you're running it locally as well. The first test case I'm giving it is agentic repository refactoring. So I've added some different Python functions in this chat window. First is to fetch the user data, then to fetch its user post basis the user ID, then analyze the engagement for those posts that is made by the user. Then I'm running the entire pipeline on the user IDs that are given. So for all the user IDs that is given in my list, I will fetch their user data, fetch their post, then analyze their engagements, and finally print everything in the engagement score. And then in the main function, I'm just going to call it for 3 different user IDs. So right now this script is synchronous, which means first it will run for first user, it will wait for the entire execution, then it will wait for the entire execution, then it will run for the second user, then it will run for the third user. But ideally we can use async operations here. While first user is running, the second user can also run, and then third user can also run, and then we can print all the 3 users requests. So that is exactly the task I'm giving, that refactor this entire module to use asynchronous functions. Once done, wait for my next prompt. I'll just press submit. So it is initiating the asynchronous processing of user data. It is refactoring the modules. So as soon as it will give the results, I will also test its reserve thinking feature, because I'm going to give it a second command in which I will ask it to implement error logging but explain why you chose specific lines based on the reasoning from the previous step. So I'm going to test it whether it remembers the exact reasoning that it took in the previous step, then accordingly add the error logs. So now the modules are refactored. It is using the async defined functions instead of the normal defined functions that I had given, which is a correct way to do it. And in the main function also it is using asyncio.run, so all three users can run in async pattern. So instead of taking 15 seconds in the synchronous mode, it will now take around 3-5 seconds in the asynchronous mode. But now I will give it the second task, again use the thinking mode and press submit. And now let's see how it reasons next. So it is refactoring the workflow, orchestrating the workflow with asynchronous concurrency. So we can also check the entire thinking process by clicking on this link, and it will show you the entire thinking process as well. So now you see in this thinking output, we are able to see that it is leveraging the asynchronous execution that it had previously built, and it is now ensuring that the delays from individual operations do not cascade across the pipelines. And then the error logging is strategically placed around each task execution and final result to maintain isolation and traceability. So it is exactly placing the error logs on the async modes that it has put in the first step. As you can see here that it has configured the logging with async friendly formatting, because it had added the async functionality in the first step, making the loggings async friendly as well. In the output also it is explaining all the previous step reasoning, that it replaced time.sleep with await asyncio.sleep. It also added try except blocks for error handling, and it also added logger.exception immediately after the await statement that it had added. Then in process user function it has added asyncio.gather to gather all the tasks. In analyze user engagement, again it is checking the previous step reasoning to keep the function async compatible. Finally for loggings also it is using try except. Finally for loggers also it is adding try except statements for all kind of errors like key error, type error, and any generic exceptions if the script gets in between. Finally for all the run pipeline and process user also it is checking the previous step reasoning. It is replacing the time.time to asyncio friendly time counters, and for logging choices as well it is adding structured timestamps, so we get the formatted time as the logger output. This will help us to check how much time is taken in the each execution and how much we are benefiting when we move from synchronous to asynchronous modes. Standard models usually just guess in these kind of tasks, but Qwen models actually trace its historical reasoning and logic graph, and that's why it hits such a high benchmark results in the long running tasks like SWE benchmark. Now we are moving to the next text. I will again open a new chat window by clicking the plus command. Ensure that 27B parameter model is selected. With this test I'm going to test its spatial awareness and its coding compatibilities by asking it to write a single HTML file containing a functional pseudo 3D racing game. And for all kind of collisions I'm asking it to include working mesh colliders, a functional reverse gear, and also a mini map for the world. Now I'll just press submit. So with this kind of mesh collider task, most of the AI models just build a single block that just collide with the floor when you actually play the game. But let's see how Qwen model is performing here. So while this code is generating, I'm going to move to the next test, which is just to check its multi-model capabilities of reading an image and information retrieval for the historical temple that I am giving. So I'm just going to give it an image which is a Meenakshi temple image. I'm just going to copy it, paste it in the chat window, ensure that the 27B parameter model is selected, and then I'm going to give this query that identify the structure first, then provide some 5 incredibly obscure structural or historical facts about what is that are not commonly known to the general public. So first it has to analyze the image, identify the temple, then it has to find some obscure facts that is not known to the general media. So I'm just going to press submit. I'm just going to check if the previous test is completed. No, it is still generating 600 lines of code. Seems like I gave some very complex task to it. So let it continue generate it, and now let's see this task results. So it is focusing on the most revealing temple of the Meenakshi Amman temple in Madurai. It is correctly able to identify the temple first. It is analyzing all the architectural features, refining the narrative, precision with depth. So it has given the outputs now that the structure is Meenakshi Amman temple, located in the ancient city of Madurai. It is one of the most significant and massive Hindu temples in the world, dedicated to goddess Meenakshi. So all the facts. Now it has given the complete 5 facts. First is that the sculptures are actually stucco, not stone. So it is saying that in the image that all these stones that we are seeing look like they are carved from stone, but they are actually not. They are made of this material, which is a lime-based plaster. The artisans first create a mold, fill it with a mixture of lime, cow dung, and sand, and then apply it to the brick and stone core of the tower. And it has also explained all the process that is there. So now let's try to search this exact fact on Google and see if it is actually obscure or known to the general media as well. So I've just pasted the same fact and added Meenakshi temple in front, and in the results I'm seeing like this kind of fact is not covered by the most prominent blot results here. Next it is saying the tallest tower has a stone finial. The massive tower on the right is South Gopuram, which stands 170 feet tall, and in the Dravidian architecture the top of tower is capped by a kalasam, a pot-like finial, which is almost made of bronze or copper. But in a real structural deviation this is actually carved from stone. Again it has given the reasoning why this structural change was done. The third fact is that the towers are cosmopolitan galleries. then there are Rangam painting cycle, and that the towers are modern additions to an ancient site. We can also test this Rangam painting cycle if it is also there in the Google results that we get. So again, I have searched Meenakshi temple Rangam painting cycle, but I'm not getting those kind of facts that it is given by the Qwen model. So Qwen correctly identifies the temple, points out the specific facts about it, and also explains the styles used in the temple, which is obscure to the general media. So this is why it is destroying the real world agent benchmark, performing better than all the previous versions, as well as beating the Claude and Gemini models. And in the real world Q&A benchmark, which is the image reasoning, it is also performing very well, beating Gemini and Claude models easily. So you can actually feed it architectural blueprints or complex server photos, and it will deeply understand what it is seeing. Now the fifth test is the ultimate reasoning test. So here I have given it a complex merging sort code written in C++ language, and intentionally added some memory leaks like this new arrays here, which I've never released in the later in the code, and assigning it pointers, and I'm asking it to identify the memory leak in this given code. Do not just fix it, output your step-by-step memory trace and explain how the stack changes at runtime before providing the corrected code. So again, I'll just select the 27B parameter model and press submit. So now it is identifying the memory leak. It is saying that the function is correctly allocating the memory for the temporary arrays, but it fails to deallocate them using delete before the function returns. Because in C++, dynamic memory that we allocate using the new commands must be explicitly returned using delete commands before the function returns. So next it is doing the step-by-step memory trace and the stack analysis. It is checking the function evocation, which is the main function here. Then it is checking the heap allocation, the memories that we are assigning. So in this new line that I had said, it is saying that the program requests memory from the system's heap. 2 blocks of memory are created, which are stored in these LNR pointers. Next, the data is copied from original arrays to the LNR arrays, sorted and merged back into arrays. But in the return, the pointers are simply destroyed, and we are losing the addresses of the heap memory that we created. So since no delete functions were called, the memory manager has no record that these blocks are free. So then it has given the corrected code in which it has added the delete commands at the end here, which is delete R and delete L. And it is also giving alternate modern fix that in C++ it is considered best practice to avoid new and delete entirely for temporary buffers using standard vector or standard array. So it has also given the code for the alternate fix where we do not use those new commands at all. So the Qwen model did not just pattern match. It gave us the complete memory trace that we asked, showing exactly the memory was made and never deleted, and then it cleanly returned the new logic and also provided an alternate solution. So this kind of algorithmic problem solving is exactly why Qwen models are performing better than all the frontier AI models on the agent skills benchmark, scoring 48% compared to the next best 45%, which is Claude, and scoring almost double than the Qwen models and the Gamma 4 models from Google. So now let's see the output generated from the HTML code that we had asked for car racing problem. You can simply download the HTML and open it. So if I open the HTML, the car racing game is generated here. If I press forward, it is going forward, and now this collision is made using this block, and it is able to correctly stop the car, and I'm not able to go forward because there is a collision. And I can also go to the reverse. So the reverse gear is also added that I had asked in the initial prompt. The mini map is also added here on top right, and the collision detection is also solid. So everything is working perfectly in the game that is generated by the Qwen model. The last test I'm going to give it is to test its native vision. I'm grabbing a 2D character sheet from opengameart.org. Just go to this universal LPC sprite sheet generator, and then just download a sprite sheet PNG from here. So this will have all kind of poses for a character. I'm going to make a new chat, add the same sprite sheet here, and I'm going to give it this prompt. I'm asking it to analyze this image programmatically, detect the pixel density and transparency to find the boundaries of the main character, and then write an HTML code to extract and animate these exact coordinates. And I'm going to press submit. So this will test if it is able to exactly find the boundaries of the character image that I have given, and whether it is able to exactly capture those coordinates and make a new animation. So now it has given me the complete HTML, which I can download and open it in a new tab. So now it is asking me the character sprite sheet JPG below. I'll just choose file and select my sprite sheet file here, and now it is able to estimate all the poses of the character and also give me an animated view of the character that I have given. In the drop down menu, you can also select some other animation sequence that you want, and it is able to automatically capture all the coordinates of the animated figure that I have given. You can also see the boundary boxes of all the slicers that it is making on different poses, and the final animation that it has generated using those exact poses. So it has completely generated the entire HTML code correctly, and due to this exceptional multimodal understanding, it is able to beat the other frontier AI models like Claude and Google Gamma in the multimodal reasoning benchmark as well. So the release of this Qwen 3.6-27B parameter model proves that you do not need a trillion parameter model to get a flagship level performance on coding and multimodal tasks. It beats frontier AI models or able to perform at par with them on most of the agentic and coding benchmarks. So you need to start learning how to prompt, test, and integrate these open source tools into your AI projects right now. If you found this video useful, just drop a comment, and you can also suggest what kind of new application that you want me to build using the local AI models. I've dropped the exact prompts and links that I have used to test this Qwen 3.6 models in the description and pinned comment below. So grab them right now and subscribe the channel for more such AI builds, updates and workflows.